Hello there. This is the first of 3 films about ionic compounds, and hopefully you've just been watching not long ago the films about metals, because there's some crossover here. As you will see, since those films were made, the chairs have started closing in. We're under attack here, but hopefully we'll make it through to the end of the film, and hopefully by the time we get there, you'll know how to predict, just by looking at the formula or the name of a substance, whether it's ionic or not, and you'll be able to draw electron dot diagrams to show how the positive and negative ions in an ionic compound form from the elements. Okay, so to start with, how do you know if something is ionic? Well, it's important, I suppose, to remember what ions are. Okay, so from the very basics of year 11, we should remember that ions are atoms that have gained or lost electrons. So if a substance, a compound made of 2 or more ions, if it's going to be ionic, if we're going to look at its name or its formula and decide that it's ionic, it's got to be made of ions. So something must have gained and something must have lost electrons. Okay, now the things that gain electrons are on the right of the periodic table. They're the non-metals. The things that lose electrons, they're on the left. They're the metals. So, in other words, a key point here is to remember that any metal, non-metal combination, look at the name or the formula, and it's a combination of metal and non-metal, then you know it's ionic. There are a very, very small number of exceptions to this rule, okay, but we'll see those in just a minute. Okay, so here we go. We've got magnesium iodide, okay, made of magnesium and iodine. Magnesium is a metal, iodine is a non-metal, so MgI2 would be the formula of this compound, but we'll have a look at how you can predict that in a different film. Okay, so we've got a metal combined with a non-metal. It must be ionic. This thing here, I suppose, in some ways has quite a similar name to this in that it ends in "ide". Okay, but we've got phosphorus here, which is a non-metal. It's on the right-hand side of the periodic table, combined with oxygen. And oxygen's also a non-metal, so this one isn't ionic. Here's the exception that I was talking about. Here we've got ammonium, and hopefully by the time you're in year 12, you'll remember this, but in year 11, you might be getting to grips with your ion list and just learning these things. Okay, ammonium bromide has got the ammonium ion in it and a bromide ion. So that's the formula of ammonium bromide. And if we look at that formula, it doesn't look like there's any metal in it. There's only non-metals. So it's just important to remember that there is a positive ion. Remember, all the metals will make positive ions. There is one positive ion that is not a metal, and that's the ammonium ion. So this substance is ionic, even though there isn't a metal in it, because there's an ammonium ion present. Okay, so moving on now, we're going to look at how you draw electron dot diagrams for ionic substances. This gets a little bit more complicated if there's covalent bonding in there as well, but we'll look at that later when we look at covalent bonding. Okay, so for the time being, we're going to keep it nice and simple, remembering that when an atom forms an ion, it's gaining or losing electrons to form a full outer shell. Okay, so sodium with the electron configuration 281. Okay, it's in the 3rd period in the 1st group, and fluoride with fluorine has the electron configuration 2,7. So sodium wants to lose an electron, fluorine wants to gain one. So sodium's going to turn into 2,8, a sodium ion, and fluorine is going to turn into a fluoride ion with the same electron configuration. We could just quickly show how that's happening. And when we do this, we only need to show the outer shell electrons because they're the only ones that get involved in chemical reactions. Okay, so there's sodium. Sodium is going to lose that one electron because it wants a full outer shell. Remember, its next shell inside is full, so it can get a full outer shell by losing that electron. But we can just draw it like that because it's lost that electron. However, when we're drawing an ion, we must put a square bracket in to show that this thing has a charge, and it's lost one electron, so it's got a 1+ charge. So there's the electron dot diagram for a sodium ion. Do the same thing to show a fluoride ion forming, but we're going to start with 7 electrons in the outer shell. Okay. Fluorine would like to gain 1, so once again we're going to show what happens once the electron transfer has occurred. We've now got 8 electrons in the outer shell, so fluorine's outer shell is full. Okay, and we're going to put a square bracket around it to show the charge. Okay, and what charge have we got this time? Well, we've gained 1 electron, so it's going to be a -1 charge. So now clearing the screen and starting again for magnesium sulfide. Right, we've got magnesium with the electron configuration 282. It's in period 3, but it's got 2 electrons in its outer shell because it's in group 2. And sulfur, just put that back for magnesium, 282. Sulfur is in the 3rd period as well, but it's got 6 electrons in its outer shell because it's in group 16, old-fashioned group 6. So sulfur wants to gain 2 electrons, magnesium wants to lose 2. Okay, so we could show the magnesium ion forming. Remember, we're only going to show outer shell electrons because they're the only ones that change. Magnesium with its 2 loses those 2. We've got an empty shell. And you might spot a pattern appearing here. Every time you draw an electron dot diagram for a metal ion, it's got no electrons in its outer shell, and all you have to do is decide on the charge. Okay, so it's quite a simple thing. You just put it in the square brackets, no electrons in the outer shell, put the charge in. Magnesium lost 2, so it's 2+. Sulfide ion starts with 6 electrons in its outer shell as an atom, gains 2 electrons, so it's going to have a full outer shell. And again, there's a pattern appearing here. All non-metals, which are gaining electrons to fill their outer shell, end up with 8 electrons in their outer shell. So every time you draw an electron dot diagram for a non-metal ion, it's going to look like that. It's just going to be the symbol inside that changes and the charge. So sulfur gained 2, so it's become a 2- ion. Pretty simple, really. You should be able to do it for any combination of positive and negative ions. So a good place to go next would be the film about naming ionic compounds. And that basically uses the ion list, so it'd be quite good to have that handy when you're doing it because you can see what we're referring to.